atmosphere, we need to take that carbon dioxide. Okay, there are two components to this. One is, ever since the industrial revolution about 300 years back, okay, so we started burning coal, we started burning oil, we started using gas. Okay, so coal, oil and gas are fossil fuels. So we've been doing that for a lot of time in our history. So what has happened is that a lot of this carbon dioxide has accumulated in the atmosphere already. Okay, so a lot of CO2 is there already in the skies. Plus, now suppose all of us are sitting here. There's fans, there's ACs, there's lights, there's this huge screen. All of this is again being powered by fossil fuels, right? So this is again being powered by coal, oil or gas. So in real time we are also emitting carbon dioxide to the atmosphere. Okay, so I want everybody to understand that there are two components. One is that there is a CO2 component due to our actions of the past. Okay, over the 300 years that we've been using fossil fuels, a lot of greenhouse gases have accumulated. It's already there. The second component is the one that we are emitting real time. Okay, जैसे आप लोग गाड़ियों में आते हो, उसका तेल जब चलता है तो CO2 निकलता है. अब घर में बिजली जब भी यूज करते हैं, तो उसका कोयला कहीं ना कहीं जल रहा है. ठीक है. Similarly, whenever we are cooking, we are using gas. Okay, so real time में भी हम सोच रहे हैं ना. So we need to ensure that the carbon dioxide levels in the atmosphere are reduced. So can anybody in the audience explain to me in like 1 or 2 lines what the greenhouse effect is? Anybody? You know what the greenhouse effect is, right? So ज़्यादा interaction नहीं करते. So greenhouse effect is very simple. So it says that the sun's rays, okay, the sun is the only source of energy in our galaxy, right? The sun sends its rays to the earth. Okay. Let's say if this is the earth's surface, the sun sends its rays, it heats up the earth's surface, and then the earth also emits those rays. Okay, like some sort of reflection of energy. Now, if greenhouse gases are less in the atmosphere, the heat that the earth reflects goes back to space. But if there is a large concentration of greenhouse gases in the atmosphere, then the reflected heat gets trapped in the atmosphere. That is what causes global warming. That is why it is important to take down greenhouse gases, most importantly carbon dioxide. Right? Now, why are trees not a good way to take down carbon dioxide? Obviously, mature trees, forests, big trees already, they are good. But if you want to plant trees today to take down carbon dioxide, it's going to take a long time for that tree to grow into a massive forest. Number one. Number two, a tree has a lot of other activities apart from capturing carbon. So, who can tell me like, which part of the tree captures the carbon? It's a very simple question. Which part? Yes. Yeah, that is a very specific answer. Yeah, I wasn't looking for stomata, but yeah, leaf would be nice. Yeah, but stomata, very very good answer, right? So, what happens is the leaf is the part of the plant that does photosynthesis. Photosynthesis is the process that takes down atmospheric carbon dioxide and emits oxygen, right? Now, think about it. Is that the only function of a tree? A tree does so much more, right? A tree takes water from the ground, like deep underground, roots, and it pumps it to its highest peak. So that requires energy. आपके सबके घरों में मोटर चलती होगी. मान के लिए मोटर चलाना होता है ना, तो क्या करते हैं वो? नीचे जो पानी जाता है, उस पानी को अपनी टंकी तक पहुँचा देते हैं. उसमें जब बिजली लगती होगी, तो ट्री को भी तो एनर्जी लगती होगी. So a tree uses a lot of its energy for this pumping of the water. Similarly, the leaves are the kitchen of the tree. ठीक है? उसमें क्या होता है? वहाँ पे खाना बनता है और बनने के बाद उन्हें फेंकना पड़ता है. That also requires energy. So if you think about it, the carbon captured part of a tree is a very small fraction of the energy used by it. हमको क्या चाहिए? हमको maximum carbon capture. ठीक है? So we are not looking at trees as the solution. We need that part of a tree that captures carbon, which is the leaf. So we start looking at specialized forms of trees. Okay, we look at trees जहाँ पे इतने activities नहीं हैं, जो पूरा energy अपना photosynthesis में लगा दें. ठीक है, तो हमको क्या चाहिए? ऐसा tree चाहिए जिसमें leaf होता है, जिसमें roots होते हैं, ठीक है, जिसमें stems नहीं होते. तो उनको बोलते हैं हम ferns, right? And today we are going to speak about this one fern called AZOLLA. The reason being, and it's one of the smallest plants on the planet. Okay, it is smaller than your finger. आपके नाखून से भी छोटा है. Now, there are many benefits to this, but the reason we are looking at this is because it has already solved the problem of global warming in the past. Okay, 5 करोड़ Hindustan like 50 million years ago, this took down 10 times the amount of carbon dioxide that we need to move today. Okay, so this is a tried and tested climate solution. And we are simply saying that we just have to recreate the past if we have to have a good future. That's our project. And this is happening in your studio. Where it's happening, how it's happening, I can't divulge right now. But like 1 month from now, you will get to know that this is happening. So I'll hand over the mic to another student from Delhi School of Advanced Studies. So she's a biotechnology scholar. So she works on the biotechnological front of this plant. And she is going to teach you the basics of this plant. So this is not the only workshop on this. So this is an introductory workshop where we teach you about the plant and why it's important. And then we are not going to talk about the project today or how we are going to save the planet, but we will. And if is going to save the planet, it is us. So I'll introduce Brahmtej Kaur Grewal from Delhi School of Advanced Studies.
Fascinating facts about AZOLLA. Imagine a plant so small and powerful that it could change the climate of our entire planet. That plant is AZOLLA. And today we are going to uncover its remarkable story. AZOLLA isn't just any plant. It's a superorganism with a history that dates back to 50 million years. It has the potential to revolutionize our approach to environmental challenges. The purpose of our time together to explore AZOLLA's unique properties, its historical significance, and how it can be harnessed in our modern world. We'll delve into AZOLLA's role in carbon sequestration, its use as biofertilizers, and its potential in biofuel production. So, as we can see, AZOLLA, nature's tiny powerhouse, fueling growth and sustaining life. Big words, no? Powerhouse and everything. Up until now, I think everybody must have heard about mitochondria being the powerhouse of the cell. Now, what is this AZOLLA? And why is it known as the nature's tiny powerhouse? So, AZOLLA, it's something that is aquatic, it is something that has potential to capture make the planet as zero carbon, causing zero waste, it is organic, oxygenating, and it can just grow in very low light, and it can be grown in lakes, ponds, it is seen there, but it can also be grown on land, and it is very useful while it comes up to talk about agriculture. Now let's unfold the next layer of this green marble. Now, I'm guys ready for some story time now? Let's take a step back, like when did it grow and how did it come into action and how did all the stories began about? So in the realm of aquatic wonders, there thrives a tiny fern, which is named as, by now everybody must guess it, AZOLLA, a green gem of the water world. Its tale begins in the verdant wilds of South America, where it was first discovered by the keen eyes of French naturalist Jean-Baptiste Lamarck in 1783. AZOLLA's lineage is ancient, with fossil records dating back to the Eocene epoch. So when this Eocene epoch, in which this time when this AZOLLA was seen, that event was known as the AZOLLA event. A time when it grew so abundantly that it consumed vast amounts of carbon dioxide, ushering in a global cooling event that echoes into our present day. It is native to many temperate and tropical regions around the world. This super fern, with its miraculous growth, can double its biomass in mere days. The fern's journey across the oceans is a tale of serendipity and chance. It is believed to have hitched right in the ballast tanks of ships or perhaps was carried as a prized ornamental plant. By the late 19th century, AZOLLA graced the waters of the Europe, first recorded in Middlesex in 1886, and from botanical gardens it escaped into the wild, claiming new territories as its own. AZOLLA has way too many names. It is known as the mosquito fern, duckweed fern, fairy moss, or water fern. And each of these names whisper of its mystical nature and the myriad ways it touches lives. From feeding livestock to adorning rice paddies, AZOLLA weaves a symbiotic tapestry with the world around it. A legacy of growth, harmony, and sustainability. So here stands AZOLLA, a plant of humble beginnings with a history as rich and deep as the water it adorns. Its story is one of resilience, ecological might, and the quiet shaping of our planet's past and future. Now, what exactly is this AZOLLA? So now what is exactly why I'm talking so much about AZOLLA? So it is a small genus. It is free-floating aquatic fern known for its rapid growth and unique symbiotic relationship with the nitrogen-fixing cyanobacteria Anavena azole. This relationship enables AZOLLA to enrich its surrounding water with nutrients, making it an excellent natural fertilizer, especially in rice paddies where it is used as green manure. AZOLLA's fast growth rate allows it to double its biomass in just 2 to 5 days, making it one of the fastest growing plants. There are 7 species of AZOLLA, all of which work with Anavena to thrive in various aquatic environments, from rice fields to ponds. They are not only efficient at fertilizing these habitats, but also serve as nutritious feeds for animals. Moreover, AZOLLA's ability to absorb carbon dioxide rapidly makes it a valuable asset in combating climate change and supporting food production as the world expands too. So, as you can see in the picture in the bottom left corner, this AZOLLA is as small as a fingernail. Like you guys can just put it on your fingernail and it is as small as that. But make sure you don't get deceived by its size, for within this tiny package lies a world of wonder and ecological significance. Now with this image in mind, let's proceed to explore the vast impact of this minuscule marvel. Let's turn a new leaf in our story and focus on the diversity within the AZOLLA family. Among the green tapestry of our planet, there are 7 distinct species of this remarkable fern. However, it's 4 of these species that often capture our attention, flourishing across various water bodies around the globe. So, the first one up right there is AZOLLA caroliniana. It is the native of eastern United States and it flows with grace in there and beneath the sun's golden cascade. Next up, we have AZOLLA folliculoides. It has its roots from the America and has spread its fronds far and wide, becoming a cosmopolitan traveler. In foreign water, it now resides. Moving on, next up we have is AZOLLA pinnata. It adorns the still waters of Africa, Asia, and parts of Australia. And last but not the least, AZOLLA mexicana. It is a native of the North America and it flourishes in the serene wetlands, a silent sentinel in the freshwater sanctuaries. So, as we navigate through the waters of knowledge, our next port of call is ecological benefits of AZOLLA. So, up right there first is carbon sequestration. A big word, no? Carbon sequestration. So, AZOLLA, through the alchemy of photosynthesis, captures carbon dioxide, a greenhouse gas, and weaves it into a golden fabric of biomass. This process aids in mitigating climate change by reducing atmospheric carbon dioxide levels. Next up we have is nitrogen fixation. Up until now you guys must have heard like nitrogen fixation occurs through the root nodules and the roots and everything from the soil. But AZOLLA is something different. With a symbiotic cyanobacterium nestled within the leaves, AZOLLA transforms the air's nitrogen into a form that nourishes the soil. This natural fertilizer enriches agricultural lands, particularly benefiting rich paddies and other crops. Now, next up we have is bioremediation. So, these AZOLLA roots delve into the water, absorbing not just nutrients but also pollutants, including heavy metals. This purifying action renders it a natural cleanser for our waterways, contributing a healthier aquatic ecosystem. sustainable feed, rapidly growing and rich in nutrients, AZOLLA serves as a sustainable feed option for livestock and fish. Its high protein content makes it valuable resource in animal husbandry, reducing the reliance on conventional feeds. Last in these ecological benefits of AZOLLA is biodiversity support. By forming dense mats on the water's surface, AZOLLA creates habitats for a myriad of aquatic organisms, supporting biodiversity and fostering a balanced ecosystem. Now, after we are done with discussing the ecological benefits, let's move on to how AZOLLA acts as a biofertilizer. Now, as we have already discussed about nitrogen fixation, that it captures nitrogen from the atmosphere and fixes it, and that's why it reduces the need for synthetic fertilizers. So, turning over a new leaf, we shall see how AZOLLA impacts the soil health. As AZOLLA decomposes, it enhances soil structure, increases organic matter content, and improves water retention, fostering a more fertile ground for the crops. Next up is weed suppression. The dense mats of AZOLLA can outcompete weeds, offering an organic method to manage weed growth and maintain the crop health. Next is pest management. AZOLLA supports beneficial insects that prey on crop pests, thereby reducing the need for chemical pesticides. Next is water conservation. By covering the soil surface, AZOLLA minimizes evaporation, helping to conserve water in agricultural systems. Last again is micronutrient solubilization. It helps in making micronutrients like zinc, iron and manganese more available to the crops, which are crucial for their growth. As AZOLLA blankets the water surface, let's cover the next topic, that is biofuel production. Now first up we have is biogas production. Through anaerobic fermentation, AZOLLA can be transformed into methane gas, a viable fuel source. The process also yields a nutrient-rich effluent that can be used as a fertilizer, ensuring nothing goes to waste. As in the beginning I told that AZOLLA stands for zero waste, so that's what AZOLLA is performing. Next up is bioethanol. AZOLLA's biomass contains cellulose, hemicellulose and starch, which can be fermented to produce bioethanol, a renewable fuel that can power our vehicles and machinery. Next up is biodiesel. The lipids within AZOLLA can be extracted and processed to create biodiesel, offering a cleaner burning fuel alternative for diesel engines. Bio-oil and biochar. Through hydrothermal liquefaction, AZOLLA can yield bio-oil and biochar. The bio-oil can be further refined into fuels, while biochar can serve as a soil amendment, sequestering carbon and improving soil health. Last is hydrogen production. Fermentation of AZOLLA biomass can generate hydrogen, a clean energy carrier with a high energy yield. AZOLLA, a plant of many virtues, is hailed as a superfood for animals, offering a banquet of benefits as follows. Just like AZOLLA's rapid growth, we swiftly move on to our next point of interest, that is as animal fodder. So, benefits as a fodder is that it is a protein powerhouse. With a protein content of 25 to 35% on a dry weight basis, AZOLLA is a robust source of nourishment, rivaling traditional feeds in its ability to bolster the health and growth of livestock. Next is vitamin vault. It is rich in essential vitamins such as vitamin A, vitamin B12 and beta carotene, which are essential for the well-being of animals. Mineral mine. AZOLLA contains a wealth of minerals including calcium, phosphorus, potassium, iron, copper and magnesium, making it a comprehensive dietary supplement. Next is growth promoter. The presence of growth promoter intermediaries in AZOLLA aids in the healthy development of animals. Digestibility. Due to its low lignin content, AZOLLA is easily digestible by animals, ensuring that they can efficiently utilize the nutrients it provides. Sustainable production. AZOLLA proliferates rapidly in water without the need for inorganic nitrogen fertilization, making it a sustainable feed option that doesn't displace existing crops or natural ecological systems. Last is omega-rich. It contains omega-3 and omega-6 polyunsaturated fatty acids, which are beneficial for the immune system and overall health of animals. AZOLLA is a little green architect of the natural world. It plays a pivotal role in land reclamation, restoring vitality to landscapes that can be degraded or disturbed. First up is soil improvement. AZOLLA enriches the soil with nitrogen and organic matter as it decomposes, enhancing soil fertility and structure, which is crucial for reclaiming degraded lands. Next is water purification. It aids in the phytoremediation of wastewater, removing pollutants and improving water quality, which is essential for restoring the health of aquatic and terrestrial ecosystem. Erosion control. The root system of AZOLLA helps stabilize soil and prevent erosion, protecting reclaimed lands from further degradation. Heavy metal removal. AZOLLA has the ability to absorb heavy metals from the soil and water, making it useful in cleaning up contaminated sites. Carbon sequestration, as we have already discussed that how AZOLLA contributes to carbon sequestration by absorbing the carbon dioxide from the atmosphere and then changing it for mitigating climate change, which is beneficial for the overall health of the reclaimed areas. AZOLLA as a plant with penchant for partnership plays a pivotal role in the verdant valley where rice, the staple of life, springs forth. Green manure. Before the rice seedlings make their entrance, AZOLLA is incorporated into the soil as green manure, enriching it with nitrogen and organic matter, setting the stage for bountiful harvest. And just skip to water efficiency, as we have already discussed about nitrogen fixation, weed suppression and pest management. So how does AZOLLA help in water efficiency in the verdant valley? By blanketing the water surface, AZOLLA reduces evaporation, which entails of water conservation to the rice fields. Last again is soil fertility. As it decomposes, AZOLLA continues to give, releasing nutrients slowly, ensuring the rice has a steady banquet of nourishment throughout its growth. AZOLLA, the green gem of aquatic environment, is not just a plant but a symbol of sustainability. It's a key player in the movement towards eco-friendly and resource-efficient practices. Moving on to green gas mitigation. In rice paddies, incorporating AZOLLA can significantly reduce methane emissions, a potent greenhouse gas, thus contributing to climate change mitigation efforts. It also helps in sustainable agriculture. AZOLLA's role as a biofertilizer supports high-yield agriculture with reduced chemical inputs, fostering sustainable crop production and enhancing food security. Habitat suitability mapping. Studies have mapped the current and future habitat suitability of AZOLLA, ensuring that its use as a biofertilizer in rice farming remains robust against climate change. Organic organic farming revolution. By integrating AZOLLA into farming systems, farmers can boost soil fertility, enhance nutrient availability, and promote sustainable crop production, all while reducing reliance on chemical fertilizers. Now, let's harvest the insights from our previous discussion as we move on to our next topic, that is life cycle of AZOLLA. So, AZOLLA propagates both vegetatively and sexually, and it can quickly multiply by breaking up its fronds, which then grow independently. This fern also reproduces sexually through large female spores and tiny male spores. The presence of a symbiotic cyanobacterium, Anamella azole, within its leaf cavities allows AZOLLA to draw down significant amounts of atmospheric nitrogen, which is then used to fuel its growth. So, as we delve into the practical side of our AZOLLA's journey, it's important to note the care that this delicate fern demands. There are certain precautions to ensure the health and safety of AZOLLA, and here is the list of precautions one must take. Don't keep it in direct sunlight, because keeping AZOLLA in direct sunlight will cause the formation of algae, and we do not need that. Use fresh, clean water which a pH of 5.5 to 7, and avoid using water with high levels of chlorine. If using tap water, let it sit for 24 hours to allow the chlorine to evaporate. Supplement the water with appropriate fertilizers if necessary, and these fertilizers are not chemical fertilizers. These are a few of the fertilizers which we naturally make for the AZOLLA if necessary. Monitor for pests such as snails, insects, and rodents that can damage the AZOLLA. Maintain a water depth of 5 to 10 centimeters, that is approximately 2 to 4 inches, and regularly harvest AZOLLA to prevent overcrowding and ensure continuous growth. So as we have reached to the final slide of our presentation, we stand at the threshold of another mode of storytelling. This visual narrative will bring to life the journey we have discussed and provide a captivating glimpse into the world of this extraordinary fern. Watch closely as we let the story of AZOLLA unfold before your eyes.
Deprived a tiny yet mighty fern known as AZOLLA. This unassuming plant, with its vibrant green mats floating on the water's surface, began its remarkable journey as an unsung hero in the quest for sustainability. As the days passed, it became clear that AZOLLA was no ordinary plant. Its incredible ability to fix atmospheric nitrogen, thanks to its symbiotic partnership with the cyanobacteria Anamella azole, was a gift to farmers. This natural fertilization process enriched the soil without the need for synthetic chemicals, making AZOLLA a cherished ally in sustainable agriculture. Fields flourished, crops grew stronger, and the soil breathed new life, all thanks to the nitrogen-rich green manure provided by AZOLLA. But AZOLLA's story didn't end there. Scientists soon discovered its potential in a different realm of biofuel production. The fern's rapid growth and high biomass made it a promising candidate for creating bioethanol and biogas. Imagine a world where energy is derived from nature's own rapid-growing green miracle, reducing our reliance on fossil fuels and bringing us closer to a greener future. AZOLLA's tale of transformation continued as it took on the role of a guardian of water quality. By absorbing pollutants and heavy metals from contaminated waters, AZOLLA became a warrior in the fight against pollution. It helped restore the health of rivers and ponds, offering a cleaner and safer environment for aquatic life. And so, AZOLLA's contributions didn't go unnoticed. Its role in carbon sequestration became a crucial chapter in its story. By capturing carbon dioxide from the atmosphere, AZOLLA played a part in cooling the planet and mitigating climate change. It stood as a testament to nature's ability to provide solutions for the pressing issues of our time. With its ability to suppress weeds, improve soil fertility, purify water, and support sustainable energy, AZOLLA's journey through the realms of agriculture and environmental management showcases its exceptional versatility. From ancient rice paddies to modern sustainability efforts, AZOLLA continues to be a beacon of hope and a reminder of nature's remarkable ability to inspire and sustain.
This video, sorry for the quality sometimes, that's because every picture or video used in this clip is from our project. Okay, so what we do is we run this project called the EOC project, where we are trying to create the EOC era. Like 50 million years, I told you 50 million years in the past, this plant actually will jump 10 times the amount of carbon dioxide we need to remove. So that's what we're trying to do. So in a nutshell, this is a plant that grows on water. So I'm just going to give you two numbers. Okay, the first number is that per square meter, AZOLLA captures 7.7 kgs of carbon dioxide per year. Based on this figure, if we want the entire world to be carbon neutral or net zero, which means that however much CO2 we are emitting from fossil fuels and other activities, we have to take that amount down. That is 1.5 million square kilometers. That is not a lot. Okay. In fact, that is just 20% of the Amazon rainforest. 20% of the Amazon rainforest is enough to make the entire world carbon neutral. Imagine that. 100% of the Amazon forest still exists, guys. Okay. Amazons are the lungs of the earth, right? So that's what we are trying to do. So it's with minds like yours that we want to impact, and we want to teach you that there are solutions already existing in nature that can solve global warming, that can solve climate change. You don't need to have a high-tech solution made in a lab that's extremely costly that comes from the USA. Not necessary. We have solutions right in front of our eyes. So that's the project. The project is we take this one, we convince people like you, we convince future leaders like you that this is the solution. And then we keep expanding till we reach this 1.5 million square kilometers. Okay, so we started this project in your school as well. The location I can't disclose at this point of time because we have to raise the culture enough before we disclose the future. But yeah, that's also going to be done in a very theatrical and dramatic way. So I'd like to invite any questions if you have any. I mean, it's very natural you have a lot of questions. So we've taught you that this is a plant that can obviously capture carbon. This can be used as animal fodder because it's highly proteinous. You can use it for biofuels. You can use it as biofertilizer. Okay, in fact, you can also use it as a substitute for food by burning it in thermal power plants to get that heat to produce electricity. So all in all, this is a plant that is too good to be true, in fact. Okay, and okay, just to make myself a little more humble, so I am not from biotechnology, I am not from agriculture, I am an electrical engineer. Okay, with zero experience with plants. Okay, so the point is, if I can do this, why can't you? Because nobody taught me this. Okay, it was just general observation. So the plan is, we are going to create a culture of AZOLLA at Kamal Model Senior Secondary School. When the culture strength becomes enough, when the quantity becomes enough, we are going to be distributing it to any student with interest. So what do you have to do? You just have to go and grow it at your place. We are going to have training workshops for that as well. I will teach you completely the end-to-end process. Like if I give you some AZOLLA, how are you going to cultivate it at your place? Okay, and you know those small round containers that we have for washing clothes and those small round, not very deep, shallow containers. So you can start at that as well. In fact, the food containers you get from schools, so my friends Swiggy, they are also good enough to start with. So if every student of Kamal Model Senior Secondary School has 1 square meter of AZOLLA cultivation, your entire school becomes net zero. Okay. To run this school, you need fans, lights, ACs, fridges, and so many other things, right? So at least global warming बाद में देखा जाएगा कि पहले तो हम कमल मॉडल सीनियर सेकेंडरी स्कूल में चलाने का जितना कार्बन एमिशन हो रहा है उसको अगर अपने छत पे ही एलिमिनेट कर पाए, so isn't that a very good model for the world? That you don't need companies to make the world carbon neutral. There's about 8 billion people on the planet. If every person just does one bowl of AZOLLA, then 1.5 million square kilometers से बहुत ज़्यादा हो जाए. So that's the thing. Everybody just has to have one bowl of AZOLLA, and the world is safe. That is the point. Okay, because everybody is using electricity. So the global warming and global emissions are caused by all of us. So how can one person or a few people save the planet? everybody is risking the planet, then everybody has to save the planet. That is the logic. Okay, so this is a zero cost solution to save the planet. Okay, so the next time anybody tells you that it costs money to save the planet, you know that they're lying. Because now you know that there's a zero cost way to save the planet. So at this point I'd like to invite any questions. Any questions. Doesn't have to be academic. You can ask me questions about me, you can ask me questions about her. If you ask, you know. If you don't ask, you don't. It's not like I'm losing out on you. Yes, is there a hand? Any questions? Yes. Take a mic, take a mic.
Of how to eliminate the pollution and other factors as well. So we took the case study of them, where we like bring the light upon the problem of Yamuna in Delhi. So there we also very interesting like in our research, and along with that we also mentioned the AZOLLA plant. So somewhere I was also doubtful that there is this capable of like eradicating pollution.
Yeah, absolutely. So that's a very good question. Yeah, really talk about your yeah, I remember you for this workshop as well. Yes. So, the main problem with the Yamuna river is that due to the organic and inorganic pollution, there is foam or froth forming on the Yamuna. Right? I think that's a video that all of us have seen. That there's foam and froth forming on the surface of the Yamuna river. In fact, this is a phenomenon that is also common in the city of Lakes, which is Bangalore. Okay. So, what we do is, so suppose in the case that if you want to use AZOLLA to purify the water of the Yamuna, okay, you can't do it in city. Okay, you cannot just put AZOLLA in the Yamuna river and expect it to be clean. Why? Because AZOLLA river is standing water, so it will not flow in rivers. Number one. What you can do is, suppose the Yamuna starts there, okay, at the right part of the stage, and the Yamuna ends here in the oceans, on the left part of the stage. What we do is, we take a channel of the Yamuna, let's say here, okay, we divert a part of the Yamuna, we put it in these AZOLLA structures that I showed you in the video, then you can easily do it on stacks because it requires low light. Unlike other plants, it doesn't require full sunlight. So you take water from the Yamuna, you grow AZOLLA, you purify that water, and then you channel that back. Okay, so it can be done ex situ, not in situ. So that's the only thing you need to do. Whenever we are talking about flowing water bodies, we cannot do it in situ. In stagnant water bodies, we can do it in situ, but we do not do it in situ. Why? Because if you are introducing AZOLLA into a pond or a lake, obviously we grow, it will purify the water. But at the same point, because there's a layer on top of the water, the dissolved oxygen of the water will go down. As a result, aquatic life such as fish, reptiles, amphibians, they might die. Okay, so we don't want to capture carbon at the cost of aquatic life. We are going to be very ethical in terms of our climate action. So that's one reason why we never introduce AZOLLA in natural settings. We always take water and then we do it in artificial settings. Yes, please. I'm doing my PhD. I'm not completing it.
So you are doing that related to this plant. So how you are contributing and what is the interest of adding up into it?
Sound like a professor. Yeah, no, it's fine. So actually, that's the professor of this plant. And you know, as an engineer, what are you doing? This plant exists. It exists without you as well. So what are you doing? So I find a patent and all right. So what are we doing inside? It's a very good question. Right? Why am I up here on the stage? Like, why should you listen to me? Okay. So the thing is, it's been known for a long time. Okay, that AZOLLA has all these benefits. So for all these years, it was used as fertilizer, as fodder, as biofuel materials. But I am the first person in the world who is talking about AZOLLA in terms of capturing carbon and mitigating global warming. Okay, nobody connected these dots before. Okay, everybody knew from earlier that AZOLLA goes really fast and it takes down carbon, fixes nitrogen, and everything. So what I have done is, So we created a system, a process in which you can cultivate AZOLLA 24 hours, 7 days in a week, or 365 days in a week, in all kinds of zones of India. Okay, and that's zero electricity. We do not use any electricity in our carbon capture. We can do it in any part of India apart from the cold zone, which is Srinagar and Leh Ladakh and all. So apart from that, in any climate zone of India, you can put me and this plant, and we can make it happen. Okay, so that's one. Number two is there's a lot of biotechnology related research that companies will be heading. Okay, so that in that what we will be doing is we will introducing a certain superpowers to us. Okay, it could be soil tolerance. Like for now, AZOLLA does not go with salt water, but through some sort of genetic engineering, we can make that happen. Okay, it does not have a lot of heat tolerance. That can be introduced into AZOLLA. For now, I don't know if you know, but when we introduce the culture into Tamil Nadu secondary school, we have to bring the plant itself. Okay, but that's a very inefficient way of transferring it. You can actually, what Ramdev is talking about, the spores of AZOLLA. You can get the spores. You can just get 140 milliliter test tube of spores is enough to inoculate about 10,000 square meters of it. So that is insanely effective. So these are the things that we will be contributing to. Okay, what is the meaning of inoculation? And things that Tamil Nadu secondary school students do not know the meaning of the word inoculation. Can anybody explain to me the word inoculation? What does inoculation mean? Can anybody? Sorry, could you come again?
If we sit in our AC and think about the planet, that how far we can think about the planet and what should be a benefit of that?
There is no benefit of that. Obviously, the benefit is that you being up in the sun. It's your intellect that matters. If your solution is good enough, then there is no use getting people about using an AC. By the way, that's not the reason why the global warming is such a huge problem. That you are using an AC or I am taking a shower instead of a bucket of water. That's not the problem. The problem is something else. Okay, so this is something that is called greenwashing, but we're not going to go into that. But yeah, I like your line of questioning, very interesting. Nice. So, that's a very good question. Amazing question. What's your name? Young man? Aryan. Wonderful, Aryan. Wonderful. Okay, great. So, to answer this question, I have to get into a little bit of philosophy. Okay, so it's a very big scientific question that nobody on the earth knows. Okay, so where did life come from? Nobody knows, right? Life is a very unique thing that is unique to this planet. We don't know where life came from, right? So there's a lot of theories. One of those theories is something called the cosmozoic theory, which says that life came to this planet via that asteroid that you speak about. Okay, and spores, if you know about it, spores can survive in vacuum. Spores can survive in space. Just like, okay, another simple question that we don't know the answer to is, where did mushrooms come from? Where did white dye come from? We don't know that. Okay, it's just there on the planet. Okay, so one of the theories is anything that reproduces through spores may have come to the earth from other planets. Okay, so I'm not saying that this is the truth, but this is one of the theories. So your question being, so in this era of destruction, 65 million years ago, I think that was the Paleocene era, the dinosaurs, right? So the Paleocene was followed by the Eocene. So what happened is there was this asteroid, as you correctly mentioned, there was this huge mushroom cloud coming, it had Earth, the Earth got cooled in a little bit of time. So the point is, first things first, you don't need humans to plant AZOLLA because we came about
It was such an enlightening and revealing information provided by our mentors. They are beautifully told about this super plant AZOLLA, and which is no less than a superhero. It has n number of benefits and is extremely advantageous for our environment. It is not only advantageous for an environment, but it also plays a significant role in our economy by playing a role in our agricultural sector as well. This little green architect is actually very cool. Besides this, what we can do at our level is we should plant more and more trees as much we can do and control the excessive use of fossil fuels. As we know, besides this, they are non-renewable as well, and be a responsible citizen. It has been such an honor to be a part of this wonderful and illuminating session. On behalf of our Kamal Model School, I would like to extend my gratitude to our esteemed guests who guided us very well. Sincere thanks to our management who organized this event and respective departments who handled the event to us.